everybody, and welcome to the Homework Helper for section 5.8. The first thing that we're going to be working on is this idea of transformations. We're not going to go too deep into this, but this is kind of like an early introduction to some things you'll see in geometry. And so you'll get a set of pictures, and you get a pre-image, which is the first image, and then you'll get an image, which is the second image. And so the transformation refers to how a figure can be moved. So one of the things we might think about are slide, flip, or turn to show how they move. So it's going to give you a couple of things and ask you how to do it. I brought out my little buddy here, Charlie the unicorn. And I'm going to use Charlie here to kind of demonstrate what each of these mean. So when we're talking about the idea of a slide, we're talking about moving Charlie in such a way that he slides from one area to another. Okay, so he's looking the same way, his head's still up, but he's just being moved around. So that's what a slide is. When we talk about a flip, it's like, well, here we have Charlie heading this way, but if I were to flip him around so that he's now going this way, it is now different. Another way we can think about a flip is a vertical flip. So like right now, his horn's pointing to the sky, but what if he turned over and now his horn's pointing to the earth, right? So that's another way that we can have a flip. And finally, we have turn. So when we're doing a turn, this is literally a rotation. So now Charlie is heading down, now Charlie is heading this way, now Charlie is heading up. And so it's all done just by keeping it and sliding it around on the paper. So when we look at like number one here, this little Tetris piece, we can imagine that it's like, Charlie here. Like, how did this piece get to here? Well, we have to imagine that we actually turned it, right? So that it rotated around, so that like you could picture it on that point, and we rotated it all the way around. Because as this little L piece is now facing down, then it became facing up. So that's all those ones are asking you to do, is to think about it like that. If you absolutely need to, you can even cut out some of these to figure out how to do it, or make your own little Charlie. All right. Next. So the set section is incredibly important because it's really putting together all the things that we've talked about up to this point. It says using equivalence to solve systems of equations. And so equivalence is going to end up being something like a substitution. But we'll go ahead and look at this. So we have Mike and Gavin here. They visited the amusement park with their science class on a school physics day. Their tickets were stamped each time they went on a ride. Mike and Gavin spent the entire afternoon going on their two favorite rides, the roller coaster and the gravity free fall. At the end of the day, their tickets were stamp shown. So these are their tickets. Here's Mike's, here's Gavin's. So what was the cost of the ride on the roller coaster, and what was the cost to ride on the gravity free fall? So what we have to do is we have to look at both of their tickets and be able to make some sort of equation out of it. So when I look at Mike's ticket, so for Mike, he ended up spending $36. And what did he spend that on? He spent that on 3 roller coaster rides and 3 gravity free fall rides, okay? So 36 equals 3R plus 3G. Now I have to look at our buddy Gavin here. So Gavin, he ended up spending $29.50, and that equaled 2 roller coaster rides and 3 gravity rides. And so now we have to figure out what R and G equal. And so here's how we're going to do this. We're going to be able to do this by solving for one of the variables. And when we're talking about the idea of equivalence, what we can see here is we have 3G and 3G. Those are the same thing. So I'm going to actually leave those on that right side of the equation. I want 3G by itself because I've identified that I'm going to substitute 3G in for 3G. To get there, I got to figure out what 3G equals. So I'll go ahead and use Gavin's equation here. So in Gavin's equation, if I subtract 2R, I end up with 29.5 equals, 29.5 minus 2R equals 3G. Okay, so now I know what 3G is. 3G is all of this. So I can actually go up to Mike's equation and plug that in for 3g, because they're the same thing. So now I have 36, I'm just copying it down, equals 3r plus, and then whatever 3g is. Well, 3g is 29.5 minus 2r. Okay, I can combine my r terms. So I end up with 36 equals 3 minus 2 is 1r plus 29.5, and I can subtract 29.5 from each side, giving me, what is that, 6.5. 6.5 equals r. So I now know that the roller coaster costs $6.50 to ride. Now, using this information, I can use any of my equations to solve for g. Okay, so let's do that. So I'll just flip it like this. Okay. So I know that 36 equals 3r plus 3g. I know that r is 650, so I know that 36 equals 3 times 6.5 plus 3g. Now I just need to solve for 3g. I can evaluate 3 times 6.5 here, 3 times 6.5 here. It's 19 and a half. So I know that 36 equals 19 and a half plus 3g. I can subtract 19 and a half, subtract 19 and a half. That's going to give me 16 and a half equals 3g. I then divide by 3 on both sides. So 16 and a half divided by 3 is going to equal g. And so I just do 16 and a half divided by 3 gives me 5.50. So I know that $5.50 is how much I spent on the gravity ride. And that's it. So the important steps for this, of course, are seeing that once we get 3g, we can just plug it in for 3g. You could have done the full substitution, solve it for r or g, and then substitute it in. But this is kind of like a shortcut that we can do, because 3 times g is going to be 3 times g. We can see that in both equations. We can evaluate it so that 3g equals something, and then plug it into the other equation. All right, next up is our go. We're going to be graphing 2 variable linear inequalities. So we're going to write an inequality to describe the given contacts, graph each inequality on the grid, then make a table to show at least 3 possible combinations that work. So Dion has enough money to buy up to 8 yogurts. His favorites are blueberry and strawberry. Okay, so so blueberry plus strawberry has to be less than or equal to 8, right? Because you can't buy more than 8. You can buy 8, but when we add them together, that's what they have to equal. So from this, we can figure out where it's going to cross our intercepts. If he buys 0 blueberry, then strawberries are going to be at 8. So 1, 2, 3, 4, 5, 6, 7, 8. And likewise, if he buys 0 strawberries, that's going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. We can then make a graph. It's going, since he can buy up to 8, it's going to be a solid line because it's or equals to. So it's going to look like this. We're going to shade underneath here. I'm just going to do a little squiggly line to show my shading because I don't have a pencil. Okay. So those represent all the different possibilities of strawberries and blueberries. It then asks, or yogurts. It then asks us to make a chart. So if I had blueberries and strawberries, what are the different combinations of these that I could buy? Well, I can just pick any 3 points within here, and it'll work, right? So I can buy 1 blueberry and 1, 2, 3, 4 strawberries. I can buy 3 blueberry and 1 strawberry, or I can buy, what is this, 1, 2, 3, 4, 1, 2, 3, 4, I can buy 4 and 4. And so if I buy 4 and 4, I'm actually buying all 8, so I'm buying as many of these as I can get. But that's all that's asking us to do. Is did we graph each inequality? Yeah, we did. Did we make a table showing 3? Yes, we did. Awesome. So we were able to do this. And that's it, everybody. Good luck on this, and we'll come back
tomorrow.